on this particular technology. The overall outline of my lectures means I'll be covering the learning objectives. What am I going to cover in this entire 1 hour, and see that how the different applications with respect to geographical information system is covered in total. Analysis, and then I will talk about the applications. So maybe I think it has got a lot of relevance in the present scenario. The reason is that this particular technology is being used all over the country, not only in India, but I think all across the world. This has been used. In fact, the applications, if you look into, they are into many folds, because the earlier times it was more focused on the natural resource management, and now I think if you look at the applications, it is being used for strategic applications. It has been used for governance applications. So I would say that the overall canvas of GIS has drastically increased over a period of time. The overall learning objectives which I'll be covering. Purposes. What are the capabilities of raster and vector data? So this is also an important component, because here we are talking about the capabilities of raster and vector data sets, and then what is the potential of GIS. So potential of GIS, I think it has a lot of applications. It has been proved that the overall applications primarily helps you to increase the GDP of your country. In fact, in India, if you look at the use of this technology has increased exponentially, because it directly relates to the business model, it directly relates to the economy of a country. So it is playing an important role with respect to making use of this geographical information system. Now, the basic unit of GIS is a geospatial data, because whenever we talk about geospatial data, the most important thing is we are talking about a location. The location, which might be a location of a point, a moving object, or anything, any location of a point, line, polygon, has a lot of significance. So basically, if you have location of a point or of an object, you can use it for navigation purposes. you can use it for decision making, and ultimately you can even make use of those information in various platforms, whether it is a social networking platforms or many other areas. So you can see that these geospatial applications has already penetrated to the life of a common man. You might be aware that Google Maps, they have been providing these data sets to almost everybody in the world, and in fact these Google Maps has opened up and has opened new era of geospatial applications. In fact, you unknowingly or knowingly, people are making use of these technologies without understanding that at the back end they are making use of GIS or GIS based applications. So the biggest example, anyway, Google Maps everybody knows because they are using in their cars or in their whatever vehicles they have to navigate them. In order to even not only navigation, you will also come to know about the traffic congestion, and even there are Google Street Views. There are so many applications which directly relates to a geospatial data. There is an application like Ola, Uber, where people are making use in the business models, and in fact the type of revenue which is being generated from these geospatial application is enormous. So it has various areas where you can use this technology, and the most important thing is, or I would say the most important parameter for GIS is you should have information about geospatial data. See, when I say geospatial data, I'm talking about the location where you have the latitude, longitude of a given area. Because why it is important? Because if you see most of the queries, most of the requirement of people is the location. Location based decision is one of the important query which people look for. Like for instance, the most common decisions is where is the nearest hospital, where is the nearest let us say recreation area, where is the nearest school, so where to build homes, where are the occurrences of natural disasters, where are crime, where are assets. So there are so many location based decisions where this technology can play an important role. So information is needed for disaster monitoring and mitigation. Geospatial technology can help. Geospatial databases for decision support, maybe for the governance application, maybe for the health application, maybe for the geospatial value chain. There are so many areas where these type of technologies can ultimately help. So now if you look at the applications as a whole, it is not possible for you to basically make use of only one technology which can give you a solution. Well, if you look at the geospatial technology, it not only talks about GIS, but it also talks about remote sensing. It also talks about inputs from GNSS. It also talks about field sensors, and of course, information and communication technology. Because when we see geospatial technology as a whole, we look at that we need to have all the geoinformation data available with us, irrespective of different type of sources, how you can store them, how you can process them, how you can deliver the geospatial reference information. Now, the most important part of geospatial technology comes through remote sensing. As you might have seen in last couple of years, remote sensing is, I would say, is one of the most important data provider in geospatial technology. Why? Because you have plethora of satellite data sets which are available, and in fact these data sets, satellite data sets, are not specific to a given country. Rather, these satellite data sets are being generated by a given satellite fall across the world. So if you really want to monitor a particular area, you can get constellation of satellites from various data providers in order to monitor. So basically, if you look at remote sensing, this is an important input which can directly be used in geospatial technology. There might be a possibility that you may not get the data for a given point of time, but you have possibility of accessing the other satellite data or other satellite data provider which can provide you a solution. In fact, there has been initiative at the international level like international charter where all the space agencies are trying to provide the data sets, satellite data sets at a given disaster. So there is there is always whenever there is a requirement, the data sets are being provided irrespective of which country satellite has taken those data sets and who is going to use it. So basically these type of convergence between the data sets from various data providers provides an important input with respect to remote sensing. There are initiatives to produce geophysical products by making use of these data sets. So those products can also be used as one of the input. I will come to GIS later. I'll talk about GNSS, Global Navigation Satellite System. This is an area where I think everybody is having a smartphone and every smartphone is having a connection for the GNSS device. So most of the smartphones make use of GPS coordinates, means global positioning system, which is an American constellation, and the GPS satellites helps you to locate the information for a given object, for a given area, and this data sets can further be used for navigation purposes or for mobile mapping. So this is an important input. The way remote sensing is an important input, similarly GNSS is also an important input because it gives you the information where even the location of an object is desired. Then we have field sensors. You can directly link your data sets if you are producing or if you are getting some data from the remote sensing sources and you really want to make use of certain validation or any you want to link those data sets with the real-time information. You can directly make use of the sensor web or automatic weather stations which do the value addition of your data sets. And in fact, field sensors or in situ measurements can help you to make your observation even much more realistic, because whenever you attach a ground truth data with remote sensing or with this technology, this adds more value to your information and you can authenticate your data sets while generating those information. Then we have information and communication technology, which primarily helps you to disseminate the information. So once you disseminate, there should be a mechanism of disseminating the information to the user. Now I'll come to GIS. In fact, GIS is a much broader phenomena wherein you can take the inputs, any geospatial inputs or any locational information which is being generated from remote sensing or through GNSS or through field sensors, can directly be integrated into GIS. So GIS is a much bigger umbrella wherein you can link all these informations together and you can model them, because when you are integrating the data from various sources, there should be a capability in your system to model them together and ultimately provide you some realistic information. So coming back to geospatial data, as I was referring to, because geospatial data matters a lot to every individual, to every organization or to every system. So basically geospatial data is a geographically referenced data that describe both location and the characteristics of the spatial features, because when you look at an object, the object location, if you talk about point object, its location means latitude, longitude is important, what is the spatial dimension of that object, and then what are the different characteristics of that object, where you can have n number of characteristics which can be associated to a given object. So geospatial data basically talks about both the spatial as well as the non-spatial data. Well, I'll give you a classic example of the London cholera epidemic, which happened way back in 1854. In fact, the concept of GIS evolved in 1854 by Dr. John Snow, who could able to relate the health or I would say cholera epidemic with location. So what he did is There was a cholera epidemic in London, and in fact there were many casualties which was happening in a given time period. So what he did is he immediately made a map of the people who died in that due to the epidemic, and the locations, the like water pump locations, because at that time when this epidemic happened, it was difficult for them to whether it was a waterborne problem or airborne. But the first thing what he did is he immediately mapped the water pumps which were installed in the given area. And the moment you can see that this map, the moment he overlaid the affected people because of cholera and the water pump, he could directly relate that this particular water pump, maybe the water pump which is in the center, was responsible for contaminated water, which is ultimately affecting the human health. So the moment this map was created, they removed this water pump. Automatically the epidemic, the effect because of the contaminated water removed, and there was no casualty. So that was a classic example that if we have these type of mechanism is available in a computer based system, or if we are able to generate these type of maps, we can really generate solutions which can ultimately affect the human life. So that way the concept was evolved in 1854, but the realistic system came into existence in 1960. You can see that it took 100 years because of the information technology, because of the computer based systems. This technology could not penetrate more into the different applications because of the non availability of the computer based systems. So basically, geographical information system, if I talk about, it is a computer based system which provides following four sets of capabilities to handle georeference data. Because here we are talking about georeference data, because anything which has got a georeference or a geospatial, or let us say geospatial information, you are able to integrate it. So you can provide the integration of those data. One can manage the data, one can manipulate the data, and one can generate outputs. So these are the four sets of capabilities which are available with any GIS based software, which can allow the integration of the data. It can allow the database management, it can allow manipulation, analysis, and ultimately the output. So these are the four functional modules which basically any GIS system has, whether you talk about open source system or you talk about commercial off the shelf system. So all systems, they provide the capability to you talk about commercial off the shelf system. So all systems, they provide the capability to input, to store, to query, as well as to output and visualization. So basically, when we talk about GIS, as I told you, that it is being used for capturing, storing, retrieving, analyzing, and displaying all the spatially referenced data. So once you have these capabilities, you are able to create the different type of tools which might be required for various applications. So basically, GIS can be a toolbox which provides set of tools, a system, and an information system. Another important part of GIS is the database definition. The database, because the advantage of using GIS is the database system, which is inbuilt into a geographical information system. So basically, it uses all the database capabilities within GIS, and it can retrieve, it can store, it can provide all type of capabilities which are available in the commercial RDBMS system. And then it can also help you to develop decision support system for various applications related to the integration of spatially referenced data for problem solving, or maybe let us say decision support system for water applications, for agriculture. So many type of applications can be developed by making use of geographical information system. So basically, it is I would say a more problem solving environment which can help you to provide the solutions for a decision-making purpose. Rather, I would not say that it will provide you an intelligent solution, but it can facilitate, it will give you certain tools, it will give you, it will provide you all the capabilities in order to develop the decision support system. So those type of applications are being developed by making use of GIS. If you look at the conventional or the significance of GIS database, because the earlier times, the most of the mapping organizations, they were only limited to analog maps. They were creating the hard copy maps. But when you create these hard copy maps, although it is really easy for you to carry those maps and you can do whatever you like if you are traveling and all. But the moment you put there are a lot of limitations with these conventional maps because they are static information. You cannot change them because if you really want to do updating in a given area, you have to really make all those procedures to generate the new maps. So once you put them into a GIS database, then creating those maps is simple for you because any updation, it is being done in a given area. You can immediately update those maps. And once you update these maps, you are able to generate those maps at a given scale. Another important component of the GIS maps is if you look at the conventional maps or you look at the hard copy maps, they are limited to certain scale. You cannot do dynamic visualization of those data sets. You cannot, they are more of scale dependent. But when you talk about GIS databases, they are scale invariant. You can do dynamic visualization. You can update the maps. You can even create a number of applications by the given GIS databases. So GIS has much more capabilities as compared to the conventional data sets. So I was referring to GIS data. So there are two important characteristics of geographic data. One is the spatial data, because whenever you talk about point, line, and polygon, you always have the features, orientation, shape, size, and structure. Where you talk about point, line, or polygon, any spatial dimension of that given object with the location is the spatial data, and any qualitative attributes or any qualitative information you are providing to the spatial data is the non-spatial data. So the combination of spatial and non-spatial data basically consists of the characteristics of a geographic data. Now, the important part, whenever we want to study any real world phenomena, these are the important, referencing, spatial referencing is important, the attributes are important, relationships are important, and the time stamping is important. So all these W's, that is where, what, and when, and how, if you are addressed to all these four capabilities, then you are able to really provide the information to the user, and ultimately it can help them to model it. So the components of GIS basically consist of hardware, software, data, people, and this basically makes a geographical information system. In the earlier times, hardware, when we talk about, at that time, people were making use of big systems, big digitizing tables, complex systems were there in order to work on GIS software. But now, at this point of time, in the present age, our laptops, our simple smart devices are capable enough to handle the GIS software data, and they can provide you, or they can help you to map or to create those data sets. So hardware is not a limitation at this point of time. Even a smaller system with limited capacity can help you to create those GIS data sets. Software, you have now plethora of data available. The software is available, like you have commercial software, you have ArcGIS, you have so many IIRS or so many other softwares are available where the commercial softwares are available. Then you have open source, you have QGIS, and there are so many open source software. So you are not limited to COTS software, rather you can make use of these open source software to really work on the GIS data sets, whether you are using it for creating the data, or you are using it for generating maps, or you are using it just to study. So either you can be a consumer or a producer there. Those aspects are anyway available with this. Then the third is the data, where data, when you talk about data, data is something where everybody wants data, and data is now available. Satellite data, especially, there are a lot of missions globally where people are trying to give free data sets to the users. So they are not only limited to a particular, because if they don't have the capacity to purchase the data, rather they can directly access the free data from various sites, from like Copernicus, or there are so many. Even for India, if you talk about, we have Bhuvan ISRO Geo portal, where the satellite data is available and one can directly download. And then people, I was referring to, whether you are consumer, producer, if you are very much aware of these GIS, this thing, you are able to create those data sets, and rather you can even help to generate different type of products which can be used. So overall, if you look at the GIS components consist of all hardware, software, data, as well as people. The sources of input data I was referring to, there are so many different type of sources which are available: remote sensing, LiDAR, hard copy maps, total station, GNSS, photogrammetry, and there are many more, where any geospatial information which are available, it can directly be integrated into GIS database, and you can ultimately develop those different type of outputs which you are looking for. So basically, the most important part of GIS is it can help you to model the real world phenomena. Now, when I talk about real world phenomena, I'm referring to those phenomena wherein you really want to capture those phenomena, whether it is related to disaster, natural disasters, artificial disaster, or anything which is happening on the ground. You really want to capture it, and you want to put that into a system, a computer-based system, where you are able to model it. So that is the most important part of any geographical phenomena. So basically, geographic phenomena is a manifestation of an entity or process that can be named or described, because every phenomena will have name, it has a location, and it has a time stamping. So all these three important properties one has to look into whenever you are creating any type of data sets or you are modeling any type of phenomena. So the naming, the georeference, and the time spent stamping are the most important properties of these phenomena. So these geographic phenomena, basically, there are different type of phenomena in the real world. Some are field-based phenomena, some are object-based phenomena. Field-based phenomena are those phenomena where there is always a slow and gradual change. So for every point, a value can be determined. When you talk about, there could be a phenomena like elevation, temperature, all these are under the category of field-based phenomena. There are another phenomena which is object-based phenomena, which has boundaries. Boundaries in the sense they are well distinguishable in nature, they are discrete in nature, and basically the space between them is potentially empty or undetermined. So basically, these field-based and object-based phenomena are the two only models or mechanism by which you can model all the real-world phenomena. Some of the phenomena will come in a field-based, some of the phenomena will be an object-based. So you can see that field-based phenomena can be converted into an object-based phenomena, like the continuous phenomena, which is something like field-based, can be converted into discrete by making use of boundaries as well as the mechanism. So these field-based and raster-based phenomena, or field-based or raster, or discrete or vector-based, these are the two data models which are being used to capture the real world. So raster model, you can think about, this is more of field-based, where every point will have different values associated with it. So they are mostly covered under the raster model, whereas the vector model, where we talk about a discrete phenomena, where you can have the boundaries associated with it, because you might be having a polygon, because that polygon represents the individual entity of a given area. So polygon or point or line will be considered under a vector model, and another model is a raster model. So raster is field-based, vector is object-based. So these are the two different type of models which are being used to map the real world phenomena. So basically, if you look at these phenomena, they are the data structure of both these models are totally different. See, if you talk about data model, that is raster data model, where we are looking for a field-based phenomena, here you are storing this data into rows and columns. So you can see that the entire entity information is explicitly recorded for a basic data unit. So you have rows, column, and you have a value. Similarly, you are storing that data into the raster data, which is more of a simple data structure. But when you talk about vector, or I would say a discrete model, or let us say we are talking about an object-based phenomena where these point, line, polygon are considered as the individual entities which can be stored, and these are under the object-based phenomena because you can see that they have a boundary, they have a spatial extension, and then the value within those entities can be potentially empty or undetermined. So basically these are under the category of vector, object-based, raster, field-based. So this is the data structure of the vector data model. As I told you, in raster, the data structure talks about rows and column. But in vector data model, since it is the object-based model, it is the discrete-based model, it takes care of coordinate pairs. So the complexity of the vector data model is much more as compared to the raster data model, because here we are dealing with coordinate pairs. So you can see that point, line, polygon, you have all the coordinate pairs, and you have entities, you have XY coordinate, and then you have the values, the attributes which are associated with those. So the difference between the line and polygon is the line will have the starting and the ending node, but the vector, the polygon will have the starting node and the ending node as same, which talks about the closed polygon. So once you have all these layers available with you, the capability of GIS helps you to integrate all these data sets together. So basically, what we do is, if we have n number of layers of a different type of vector data sets, you can put them together, you can model them, you can apply any type of criteria to those data sets, and ultimately, like for instance, you want to do a site suitability analysis, or you want to make use of certain algorithm to reclassify, or to, let us say, generate new maps from those given data sets. It is possible with you because GIS allows you to integrate all the data sets together. But the important part of these, the overlay analysis is vector can be overlaid separately, the rasters can be overlaid separately, because since they have a different data structures, they have to be overlaid because their capabilities are also different. Another aspect of GIS is data types and values, because whenever you really create those different type of, you want to model those phenomena, you have to consider that how you will represent those maps, how you will be depicting those maps in the form of the legends with different type of symbologies to be used. So basically, there are two types of data values which are being considered for modeling the different type of phenomena. One is a qualitative data, another one is a quantitative data. Qualitative data is they are those data sets wherein basically you only try to provide the qualitative aspect of those data sets. So within qualitative, one is categorical data, another one is ordinal data. Categorical data is those data sets where you are defining the individual entities, though they are distinct in nature, and they can provide the very specific information, like for instance, land use land cover map or soil type map. So those they are totally independent to each other, and they are categorical in nature. The second category is ordinal, where you are trying to provide the high, medium, low ranking. Means you want to show a map where you only have to depict the order or the ranking with respect to other. So the relative ranking can be done by making use of ordinal data sets. So these two categories, nominal, categorical, and ordinal, they come under the category of qualitative. But when you talk about quantitative data, there you are actually providing the estimation of those values. Basically, either you provide those data in the form of interval data, or you can provide those data in the form of absolute values. So if you have these information available, data having known interval between values and data having absolute values, you are able to provide the actual information which people are looking for. So basically, you can see that this is a land use land cover map where you are providing the different colors with different categorical information which can serve the important information. Similarly, you can club different type of data values, whether it is from nominal as well as interval, or this type of data sets can be integrated together in order to depict any type of information which you want to basically provide to the user, because you cannot have multiple legends given in a for a given map. So basically, you can make use of this different ways and means to depict this information. You might be aware about in fact, everybody experienced the havoc of this pandemic, COVID-19, and in fact, the important aspect is the moment this outbreak was declared, the John Hopkins they immediately developed this dashboard, which primarily provides a visualization mechanism of the incidents which is happening all across the world, and how the entire this pandemic is behaving from country to country. So those type of visualization can ultimately help you to understand the overall the how it has affected across the different part of the country within a given frame. And also the vaccination, the incidence cases, all those aspects can be directly visualized by making use of these type of dashboards, which was developed within a very short span of time. Because see, why this is very important, because if you really want to make use of these data sets, or if you really want to make use of this information and people really need it, so there should be a mechanism of providing these information in the public platform. So GIS or GIS based systems allows you to create those type of spatial dashboards which can help you to understand and to ultimately provide information. So there are different type of spatial data models, for instance, in fact, there are a lot of analysis one can do with the help of GIS data sets, because once you have these data sets created, so you can query different type of information which might be related to location, it might be related to condition. Means if you really I want to see those areas where the size or the area of a particular this thing is X. So you can apply any type of conditional operations to your requirement. The GIS provides all those mechanisms to address that. Then it also provides the trend analysis. It also provides pattern analysis, and also it helps you to model the real world scenario. Means what if scenarios can be developed if you really want to see that if there is any change in a given parameter, how the system will behave. So a lot of simulations can be carried out within the GIS framework, and ultimately it helps you to understand the phenomena in a better way. So all these aspects, I think whatever I'm showing you at this point of time is just a very small capabilities. Rather, it has got much bigger capabilities compared to what we have now. So if you look at the different type of the analysis one can do, like I was referring to, where is the nearest school to my home, choosing where to locate a new suitability area, what are my intended routes, and how modeling effects of LULC on site. So these are some of the examples by which you can make use of your GIS based analysis. So it all depends whether you are making use of simple query, are you making use of spatial query, are you making use of single layer operation, multi-layer, surface analysis, network. So there are so many analysis one can do it by making use of these GIS operations. Now, as I told you that we already have different type of raster analysis and vector analysis. Basically, since we have two type of models which are being used to model the real world phenomena, so you can see that since their data structures are different, their analysis are also different. So they have certain set of analysis which works on only on the vector data sets. There are different type of analysis which only works on raster based analysis. So you can see that vector, you can do the map overlay. There are union intersection operations. I think all these operations will be told to you in detail once you come up with these lectures. Similarly, you have map manipulations, dissolve, clip. All these operations are vector-based operations. Similarly, in the you have proximity analysis where you do the proximity analysis means how the if you put a buffer of around 100 meter, 200 meter, 300 meter all along the road or along a river channel, anywhere you can study those areas in a limit according to the proximity. So those type of analysis, and even there are different type of operations which are very much specific to proximity areas. So those type of things you can do. Then you can even do pattern analysis, spatial autocorrelation, nearest neighbor analysis. And then you have networking analysis. This is the shortest route analysis, where basically what you do is you make use of certain the network routes which are being defined in a vector data model. In fact, for the networking analysis, the topology or the data structures are totally different what you have for the other vector-based information. So here, basically, you might have seen in Google Maps the routing analysis, like routing from one place to another. The moment you take a wrong route, it automatically recalculates and generate a shortest route. So those type of networking analysis applications can ultimately help you to provide some realistic information which can be used or which is being used by many people. So when we talk about raster, you have different type of functions. In fact, raster-based analysis is quite common, like your image processing operations, where you do like functions. When you look at local, focal, zonal, global, different type of functions are available. It is pixel-based, kernel-based, zonal-based, and even if you really apply certain type of operation globally. So those type of functions are available in raster. And similarly, you have map algebra operations, like you apply operators, Boolean, relational, you have functional, mathematical, logarithmic, trigonometric, power. So all these map algebra operations can be applied, and ultimately any mathematical algorithms, if you really want to apply, you cannot apply in vector, you can only apply on a raster-based analysis. Then you have terrain analysis. These are some of the applications which are being developed within the GIS framework, because when you talk about elevation, you go for first order, second order derivatives. So the raster-based analysis provide flexibility to create those different order derivatives which can be directly used. Then you have hydrology analysis, flow accumulation, flow. And these are some of the examples which I am just putting before you so that you understand the capability. And reclassification anyway is one of the most common tool which is being used in raster-based analysis. So these are the different type of operations which I'm trying to show you. The map overlaying involving the integration of multiple data layers like vector-based and raster-based. So here you can see that how the different type of vector as well as raster, since their analysis are different, their overlaying the outputs are also different. Like here we can see that how the vector overlays are there, two vector overlay. When you overlay them together, all the information with respect to the polygons are captured in the output, and not only the spatially you are capturing their polygon information, but also you are capturing their attributes. So you can see in table A and B, both the attributes are taken care within the overlay vector operation. Similarly, when you talk about raster-based analysis, so here you can really apply these arithmetic operations. As I told you that these arithmetic operations could be a very simple mathematical operation, or you can apply any complex mathematics to these data sets. And when you apply these complex mathematics to those pixels, you are able to get a lot of information which you are looking for. So any relational logical operators, conditional statements, arithmetic operations, all these things can be easily applied on a raster analysis, but not on vector, because vector data model never supports these type of operations. So these are some of the classic examples of the map overlay in the raster data analysis. You can add, you can apply all these different type of operations. So basically, if you look at the applications, I think there are unbelievable applications which are there in GIS. You talk about natural resource management, you talk about disaster management, you talk about land use planning, infrastructure, utility services, e-governance. Governance is I think you can see that the effect of these applications are visible to a common man, because they can really make use of these applications, or they can make use of these data sets or these information for ultimately deriving the information. Public health or geo health is an important area, because now the most of the organizations they are trying to study that how the health as well as GIS technology can contribute to each other. Because if there is a convergence between these two, the epidemiology as well as the GIS, it can really provide those hidden information which people are looking for. So health, geo-health is an important area where people can really work and they can provide some important information. Tourism GIS is another area, crime GIS is another area, and then GIS for supply chain management. These are really good information, because supply chain has direct relevance with respect to geospatial data, because the entire supply chain primarily deals with geospatial data right from the beginning of capturing the information, processing it, and ultimately going till the user. So all the geospatial value chain is involved in supply chain management. And this, if people are making use of this technology, it can really provide you some important attributes which can help you to generate more finances and better decision making. Well, if you look at the emphasis is little bit different in the present scenario, because in the past we were only busy in creating the data sets. We were only trying to make the spatial data infrastructure of our own country, irrespective of different type of scales. But you look at the present scenario, data has been collected. Data is really in a voluminous size. Only thing is you have to see that what hidden information or what analytics I can do it with those data sets. If I am able to generate those type of information from a given data, I can really provide the information which any government is looking for. So basically, I would say that it's more of a data science, or it is more of machine learning or artificial intelligence, deep learning based algorithm has to be explored in this area, so that you can really come out with a solution where it can provide you some new openings. So there are, if you look at the learning outcome, I think we have covered the understanding of GIS concepts. We have talked about the data models for capturing how you can real world, you can capture those information. What is the significance of these data models? What are the analysis capabilities of raster and vector data? And in fact, there was one concept of topology, which because of the time constraint, I did not talk about, because topology is basically, it tries to make your data, the data correctness is stored in the vector data model. So basically, whenever you create these vector data sets, you have to make it topologically enabled so that all errors which are associated with the vector is being removed, and you can apply any type of transformation to those data, and ultimately it is not going to affect because it is following a topological model. We have talked about advantages and disadvantages of raster and vector, selection of data values in a map, and various applications of GIS. Various application of GIS is not, I have just given you an overview, but I think you will be having some application lecture which will make your understanding even better. So these are some of the references, and in the end, I would like to mention that the application of GIS is limited only by the imagination of those who use it. So it's a good saying by Jack Tengermont. So with this, thank you very much for listening and for joining with me on this particular talk. Thank you so much once again. Hello, hello. Can we have questions from the participants? Hello, I can't listen. Hello, yes, below the, do you have question?
Hi everyone.
Hello, yeah,
Yeah, it's Vishal from
yes.
Mauritius.
Oh, very good.
It was nice. Your show was very nice. Um, can we have the soft copy of the slideshow?
Yeah. We'll send that to the coordinator, and coordinator will further send it to you. Okay?
Okay, sir. Thank you very
Yeah.
much.
Thank you. Yes, Bodhi Jiva.
Mm. Please, can we develop our own package or of spatial analysis like a change detection using open source software? Or
Yes,
how
yes, yes. You,
can
you,
we do
you.
that?
Yeah. It is very much possible. In fact, I was referring to our open source community. There are so many tools are available by which you can directly develop the open source, especially QGIS. I think most of the tools, because this is being developed by open source community, so you can make use of the existing APIs or existing functions which can directly be, because they are taken from the open source library. So you can easily develop any type of customized package from the existing open source tools. Okay.
Okay, thank you.
Yeah. Spatial analysis, there is one question on spatial analysis. Can you explain? See, basically, spatial analysis, we will be having a dedicated lecture. Only I was just trying to tell you that once you have the GIS data, whether it is in raster or in vector, you can model these data sets together. So, like suppose if you have vector data, you can apply different type of union operations. You can apply any type of different modeling scenarios, interpolations, all those are part of the analysis. Even if you fire any type of query, that is also part of spatial analysis. So there are different type of analysis operations available both in vector and raster. So very soon you will be maybe after few days the more dedicated spatial data analysis lecture will be there on vector as well as raster. So maybe because here only I'm trying to give you an overview, but the detailed spatial analysis lecture will be taken, and you will have even much more rigorous aspects told in that particular lecture. Okay. Okay. Do we have any other question? Uh, Earth revolution and changes in radius to sun affect GI. I think this is totally different aspects because we are not talking about the Earth revolution and the different changes in the effect. So I don't think we are dealing with this particular aspect in our lecture, and we won't be covering all those aspects, the Earth revolution and all those things. So we are only talking about the GIS-based models, and in fact, how these data models can be integrated into computer domain. Okay. So thank you very much for connecting, and maybe in future lectures try to see that how different components of GIS ultimately helps you in a decision making or developing any type of geospatial application. So thank you so much.